Okay, we're going to talk through a few examples of solving two-step equations, and then at the end of the video there'll be a small task for you to pause the video, complete the questions, and then check your questions. So we are dealing with linear equations. So if you're asked to solve this equation, 3y plus 2 equals 14, the aim of the question is to find the value of a single y. Okay, we need to use an algebraic method showing our full working out in order to find that solution. I refer to the type of questions as a two-step equation because there's going to be two important things, two important processes that we do throughout the question. The first step is I'm going to look at this positive 2, this plus 2. I'm going to take this plus 2 and I'm going to add and I'm going to move it onto the other side. Okay, when we move something across the equal sign, the function changes, the sign changes. So this plus 2, when it moves across the equal sign, it will become a minus 2, a negative 2. So essentially, I'm taking the plus 2, taking it over the other side, and it's becoming a minus 2. That's not a very mathematical way to think of it. One way to think of it is that we've balanced each side of the equation. We've subtracted 2 from this side of the equal sign, and at the same time, we've subtracted 2 from this side of the equal sign. But sometimes visualizing moving the 2 and changing the sign is a little bit easier for students to understand. But mathematically what we've done is we've subtracted 2 from this side. At the same time, we've subtracted 2 from this side. Now we're left with 3y equals 14 minus 2. I'm just going to tidy this up here. 14 minus 2 we know is 12. So I've now got 3y equaling 12. This is now the second step of the two-step equation. 3y in algebraic terms means 3 multiplied by y. If we can't see a multiplication sign and a letter and a number are just squished together, in algebra that means multiply. So we're going to take this multiply by 3, we're going to move it over the equal sign, and it's going to change to the opposite function, which is divide by 3. Again, mathematically speaking, we're balancing the equation. We're dividing this side by 3, and at the same time, we're dividing this side by 3. That leaves us with 12 divided by 3, which we can go ahead and simplify, which tells us that our value of y is 4. So the two-step equation, you can see where that took place. The two steps are where the blue arrow indicates that something is moving across the equal sign, or we are rebalancing the equation. If we take the number 4 and substitute it into this equation up here, so if I substitute the number 4 as y up here, we should get the answer 14. So if I did 3 times 4, which is 12, then I added on the 2, I'd be left with 14. So I've double checked my answer to make sure I've solved the equation correctly. Take a look at my working out though. This method is what is expected. This algebraic method showing each step and showing a full understanding of the question. Okay, another question, very similar. 2a plus 1 equals 13. A lot of students might be looking at that question and are able to solve it in their heads. But a big emphasis of the lesson is on method and notation, because once we get onto more difficult equations, the algebraic method becomes very, very important. So please do not try to answer these in your head and just rush to the end. First thing I'm going to do is I'm going to subtract 1 from this side, and at the same time, I'm going to subtract 1 from this side. So I've took the 1, moved it to the other side, it becomes a negative 1. That is the equivalent of subtracting 1 here, at the same time subtracting 1 here. Tidying up and simplifying, 13 minus 1 gives me 12. So I now know that 2a is equal 12. 2a means 2 times a. Opposite of multiply is divide. So I'm going to divide this side of the equation by 2, and at the same time I'm going to divide this side of the equation by 2. The 2 moves from here to here and changes from a multiply to a divide. 12 divided by 2 tells me that the value of A equaling 6. Again, the method and the notation is vitally important. Do not just jump from the question to the solution down here. That misses out all this algebra notation, which becomes very important as we work our way through the algebra topic. 4b minus 2 equals 22. First step of the equation, I have a negative 2 here, a minus 2 here. So I'm going to add 2 to this side of the equation, which means I need to add 2 to this side of the equation. That is the same as taking the minus 2, moving it onto this side, and making it a plus 2, because the function changes from a minus to a plus as it goes over the equal sign. 22 plus 2, we can simplify that by adding it together to give 24. 4b equaling 24. So I'm going to divide this side by 4. At the same time, I'm going to divide this side by 4. Take the 4, move it over here. It changes from a multiply to a divide, which leaves me at 24 divided by 4, telling me the value of b is 6. Again, take a look at the full notation, the full method. Everything's nice and neat. My equal signs are in a nice straight line down here. Everything that occurred on this side balanced out with what occurred on the other side. A couple more examples. 3c minus 7 equaling 14. I'm going to take the minus 7 and I'm going to add 7 to this side. I'm going to add 7 to this side, which is the equivalent of taking the minus 7, moving it to the other side, and making it a positive 7. 3c equaling 14 plus 7, which we can simplify to 21. So I now know that 3c's have the value of 21, but to solve an equation, I just want to know what 1c is worth. So I take this multiply by 3, move it onto this side so it becomes a divide. So I'm dividing each side of the equation by 3, telling me that the value of c is 7. Okay, so there's a few examples that I've worked through there showing you the method. I'm about to give you a set of questions. If for each question you could set out the question using your full notation and full method, making sure you're showing me the 2 steps, balancing each side of the equation. Remember, if you want to check your answers, you can take your answer, substitute it into the original equation, and see if you get the correct answer. Okay, so there's a set of questions to do. If you could please work through all 12 questions, showing me the full method. If you could pause the video at this point, working through the questions. When you're finished the questions, if you unpause the video, then there'll be some solutions for you to mark and check your work. So if you'd like to pause the video now. Okay, welcome back. Hopefully you've had a go at all 12 questions with full working out, some nice neat notation, some nice neat algebra work. My solutions look something like that. So those are my solutions to the equations that were just displayed. If you could use those to mark up your answers and assess your answers, remember that the working out is just as important as those final solutions.